So now let's go back to the original problem. We have these two functions, natural log of x, that's in blue, and x e to the minus x, that's in orange. And we'd like to, the original prompt was solve this equation. And we're backing up a little bit on that to start, and then we'll come back to it at the very end of the video about how you would more precisely solve it. We just want to get a sense of, is there a solution at all, and assert there is one, and some vague idea of where it would be. And then we can make it more precise from there. It's a really nice thing to even know there is a solution at all. So what I was suggesting there is call this f of x. And we're interested in, is that ever equal to g of x? And just a standard technique of algebra is to put everything on one side. So a little more fancy way to do that is say, let h of x be the difference. And explicitly, that's just given by the formula natural log minus x e to the minus x. Okay, and I'm really then asking to solve h of x equals 0. Or, a little bit weaker, can we even assert that h of x equals 0 has a solution? Well, that's going to have a solution exactly where these two functions are equal, so it certainly looks pictorially like somewhere between 1 and 2 there should be a solution. And IVT, carefully done, can exactly tell us that. So let me see if I can fit it in up here. Because what do we know about h? We know that, well, f and g are continuous. That's important. This is from our big theorem on just library functions, basically, and putting together library functions. There's nothing suspicious about this, given that I'm avoiding 0 or negatives where ln x isn't even defined. Natural log of x is pretty not defined. It's not nice at all, in our world anyway, for negative or 0 values of x, but we're avoiding those. We're over here in positive values, and this is perfectly nice. So these are continuous, and therefore we also have a nice related theorem, about putting together two known functions that are continuous, and the difference of two functions is always continuous. The tricky one is if I were taking a quotient, because then I'd have to worry about zeros, and that could totally screw me up. That could really invalidate what I'm trying to do, but I'm just taking the difference. So h is continuous. That's one of the things we need for IVT. We also note that h of 1, we have this table, is a smaller version of the table we had before. These two values were crucial because between x equals 1 and x equals 2 is where they switched places, f and g. Therefore, the difference, well, h of 1, that's where f minus g was negative, and h of 2, that's where f minus g is positive. So this function is a continuous function, and we have a particular value that we'd like to know it's equal to. Notice the 0 is part of the given data that we're interested in. We're interested in where this equals 0 specifically, not some other value. And we have now done a calculation to show that it goes from one side of 0 to another side of 0. Okay, so then IVT says there is some, let's just call it C, there's nothing magic about that, C, and specifically in the interval 1, 2, surprise, surprise, somewhere in here with h of c equals 0. And what does that really mean for us? It means that f of c minus g of c equals 0, or in other words, where f of c equals g of c. So that just confirms really carefully what it looks like graphically, that it really does seem like there's a solution here, and we've confirmed, yes, there really must be. So one thing, like I'll mention, so how would we push that a little further? All that it tells you is there's something between 1 and 2. That's a pretty weak approximation. It's not a whole lot of significant figures, you could say. But you can continue this in a nice way. You can just say, well, let's test it at 1.5. Let's see who's on top, orange or blue. If it's what it looks like in this situation, if orange is still on top and blue is on the bottom, and then at 2 they've switched, that means, in fact, that you must be able to find a solution between 1.5 and 2. Then you could try 1.75 and see which side of 1.75 the crossing's on, and then 1.875 or whatever. And you can just zoom in sort of by factors of 2 or whatever kind of zooming you want to do. As long as you can calculate some explicit values, you can start narrowing this down. That's actually a perfectly good way of getting a numerical approximation to what this magic value of c is. So you can turn this into a very explicit procedure for getting an approximate solution. Remember that with this kind of equation, these two things being equal, That's as good as we're going to get. There's no nice answer to this. We could just get better and better decimal approximations. And it's all based on this idea of if you see them switching roles, who's on top, there must be a crossing in between. And why? It's because of IVT. Okay, and so I might put together another video or two about how to avoid getting tricked. You don't want to use IVT where it's not appropriate, but here is a case where it was absolutely appropriate.